Welcome to 20th lecture of course Polymer Science and Technology. We will see the measurement techniques for the glass transition temperature. The glass transition temperature and the melting point can be determined by the several experimental techniques like determination of refractive index, NMR, birefringence, dialectometry, differential scanning calorimetry, dynamic mechanical analysis. These are the characterization techniques. So TG can be determined by any of these technique, but the most favorite technique for the determination of TG and TM are the dialectometry, differential scanning calorimetry, and dynamic mechanical analysis. So we'll see the dialectometry. Dialectometry is the oldest method, and it gives us a relationship between the specific volume of the polymer versus temperature. And heating rate is kept from 1 to 2 degrees centigrade per minute. The construction of the equipment is like that. There is a capillary, glass capillary, and which is attached to a bulb, glass bulb containing mercury and the polymer, and upon heating the polymer will expand, so it will displace the mercury surrounding the polymer, and the displaced mercury will rise the level in the attached capillary. So we can measure the value of delta V by observing the level of the mercury in the capillary. And this whole setup, which is made up of purely glass, can be kept inside a precise temperature controlled water bath, where you can increase the temperature of water bath at the rate of 1 to 2 degrees centigrade per minute. And with respect to temperature, you can measure the specific volume. Okay, so you can easily measure the temperature of water bath, and you can measure the value of delta V from the capillary. So you can plot a specific volume delta V versus T curve, and you will observe that this curve will change its slope first time near the glass transition temperature, whereas it will again change its slope for the second time near the melting point of the polymer. So easily you can find out the glass transition temperature and the melting point from this dialectometry experiment. At TG, the slope of temperature versus a specific volume curve will change. So wherever you observe change in slope, the point below the value of temperature below that particular point will indicate the glass transition temperature. In the second method, this is a differential scanning calorimetry, and I think I have discussed this method in quite a detail in first unit. So I'll go briefly with this technique. So there are two ovens, basically one is the sample, another one is the reference, which contains the sample contains the polymeric sample, reference contain empty pan. Okay, and there are two temperature sensor, PT sensor. They will measure the temperature of each individual oven, and heater is associated. This heater will provide electrical energy to heat the oven. So basically in DSC we will measure the differential heat flow to keep the temperature of both the pan same. Since the sample pan is containing polymer, so there is a mass, it will need more energy as compared to empty pan. So the differential heat flow to sample oven will be more than the reference oven. Okay, but in case of some exothermic event, just like a crystallization of the polymer, heat will be liberated from the polymer sample itself. So when some heat is liberated from the polymer sample, so in this case the requirement of heat to the sample oven will be less than the reference pan. Okay, so individual heaters are maintained at equal temperature. Temperature are measured by the use of identical platinum resistance thermistors. They are known as PT sensor also. Differential power needed to maintain both reference and sample pan at equal temperature. You cannot give the same amount of energy input to sample pan as well as reference pan, because one is containing sample, another was empty. So their thermal inertia or the thermal capacity of these two ovens are different. So in order to maintain them at the same temperature, you have to provide differential amount of heat. Differential amount of heat means different amount of heat to the sample and different amount of heat to the reference pan. Differential power can be represented in the form of heat flow. So this is the curve how we can plot the heat flow. Heat flow, it's customary to express the exothermic region in upward side and endothermic in the bottom side of this graph, and on the x-axis temperature is there. So when you will heat the polymer, which is below the glass transition temperature somewhere here, so when it will reach to the glass transition temperature of the polymer, this event is endothermic, because at the glass transition temperature polymer chain will absorb the heat energy and they will undergo segmental mobility. So because of this segmental mobility, you will observe an endothermic transition in downward side. And if you draw a vertical line from the mid of this transition line, so it will indicate the glass transition temperature on temperature scale. Then upon further heating the polymer, you will again observe a large peak, and this peak again represents the endothermic event, and this endothermic event this time is the melting, where the polymer chains will absorb lot of energy to become mobile inside the polymer matrix. Okay, so the temperature just below the peak of this just below the peak is the melting point. Okay, and if we further heat, the polymer will decompose, it will undergo degradation. And if we start cooling after the melting, then we will observe a crystallization peak near the crystallization temperature, and crystallization is a exothermic. That's why the direction of the peak is in the exothermic direction, in upward side, and temperature just below the exothermic peak is known as the crystallization temperature, peak crystallization temperature. So this all I have already discussed in my lecture 1. So here with the help of glass transition temperature you can determine the, here with the help of the differential scanning calorimetry you can determine the glass transition temperature. So this is the end of this lecture, and probably this is the end of this unit, and we'll now in the next unit we'll see the different techniques for the polymer processing. So thank you very much for your patient hearing. Thank you.